Hello and welcome to the KPI Institute's webinar, Data Analysis, Sampling, and Hypothesis Testing. My name is Andre Costa and I will be your host for today along with our presenter, Fadi Fuad Al-Jafari. This webinar is part of a series of free educational materials that aim to enhance the knowledge and know-how of those interested, while also creating a bridge between us as a company and you, our public. The KPI Institute is a research organization specialized in business performance. It operates research programs in 12 practice domains, each linked to a certification course, ranging from strategy and KPIs to employee performance, and from customer service to innovation performance. Today, 15 years after the KPI Institute was created, we can proudly say that our products and services have reached professionals on 5 continents, and that our public comprises a worldwide community of around 8,400,000 members online and 30,000 registered companies on smartkpis.com. Today's webinar will focus on performance measurement, specifically on how data should be analyzed using different tools and techniques in order to get a better understanding of the operations, market, and customers. This presentation will be delivered by Fadi Fuad Al-Jafari, specialized in data analysis and data visualization. He has delivered multiple training courses in 4 countries in data analysis and visualization. Fadi has several certifications in Statistics Foundation, data analysis using Excel, analyzing and visualizing data with Excel, working with real-time data in Excel macros in depth, predictive analytics using BigML, and he has been part of several projects in the last years concerning data analysis. This presentation will last approximately 40 minutes. Please feel free to ask any questions you might have during the webinar, as they will be answered at the end of the presentation in our Q&A session. Enjoy the KPI Institute's webinar, Data Analysis, Sampling, and Hypothesis Testing. Now, I would like to invite Fadi to begin his presentation.
Thank you very much, Andre, for the introduction. Hello, everyone. I hope you will enjoy the time that we are going to spend together discussing the topic data analysis, sampling, and hypothesis testing. As per our agenda, this webinar, we will discuss 5 different topics, and they are data analysis, the process, the key concepts and steps within this process, relevant data analysis techniques, hypothesis testing using different methods and key concepts, the importance of sampling and what is its process, the impact of data analysis on decision-making process, and finally, we will close up with Q&As. The learning objectives of this webinar are going to help us to understand the need for data analysis in business, understand how we can get benefit from the data to help in decision-making process, how to use Microsoft Excel data analysis tool, learn about hypothesis testing procedure using different hypothesis testing, and how to interpret the results we got from the analysis. The first topic, and it refers to data analysis key concepts. In this moment, you can ask yourself, what are the key concepts that we should know about data analysis? What is the process? And what are the different types of data analysis? So, what is data analysis? Data analysis represents the process of evaluating data using analytical and logical reasoning to examine the components of data sets by researching, organizing, and manipulating data to bring useful insights from available information. Mainly, we have 5 major types of data analysis, and the majority and complexity of data analysis tools, techniques, and concepts are increasing when we move upwards on the scale. The main 5 types are descriptive analysis. It is the type of analysis that gives us a hindsight from the data and studies what happened in the past. Diagnostic analysis. This type of analysis that gives an insight from the data and studies why things happened in the past. So it's connected and complementary to descriptive analysis. Predictive analytics. It is the type of analysis that gives us a foresight from the data and studies what will happen in the future, why and when. The fourth type, perspective analysis. is the type of analysis that gives future sight from the data, as it is simulation-driven analysis and helps in decision-making. And cognitive analysis is the type of analysis that use machine learning and artificial intelligence to learn from data, make automated simulations, and take actions. The data analysis process starts by having an understanding of our business situation. What are the objectives and intended purpose of collecting the data? Like, let's say, studying the market, measuring satisfaction level, or even predicting future sales. After identifying the purpose, the data will be collected from multiple sources and using different collection methods. Moving forward, the data will be assessed and compared with different data quality dimensions to evaluate the type of data cleaning techniques that should be used. This is the data preparation step. After cleaning the collected data, the analyst's job in this step is to explore the data by using simple data visualization techniques, trying to summarize the data and to find the proposed relationships to get a better understanding of the data in hand. After exploring the data and understanding it, the analyst will have different options and analytical methods to use based on the main objective, either by using statistical analysis, machine learning, or artificial intelligence tools, to get results that will be interpreted and used in decision-making process. In today's world, technology has made collecting huge amounts of data possible, so that lead to having a massive amount of data available in almost every business. And the availability of such data can help organizations to make better decisions about their operations, sales, or projects. But the key to use this data is to ask the right question in the beginning and to use the right tools and techniques to get the desired results. Analyzing and uncovering the information hidden in the data will help in decision makings, as decision makers will act up based on this information to make future decisions. Examples of fields that extensively use statistical tools to analyze the data are in stock trading field, in the marketing field, as we all know, in the weather predictions, in the politics field, and in medical research. So, when it comes to how data analysis helps in decision making, I will mention the following examples. So let's say marketeers can analyze customer databases to know which segments are likely to respond to various products and different types of promotions. In this example, this type of analysis will help marketeers to identify the segments precisely and target them specifically instead of targeting the whole market. And as a result, this will help them to maximize their profits and minimize their costs. Another example, when it comes to financial planners, they can analyze customers' data to make informed decisions for them about different preferences for various types of investments. Another examples from different organizations, when operational departments, how they can get use of data. Operational departments may use the data analysis, let's say, to identify bottlenecks in their operation using data analysis and statistical tools. So the organization must start with asking the right questions and defining a clear objective of what they are looking for. Then they will start collecting and gathering or extracting the data from different sources, then aggregate them while considering data quality dimensions. After collecting and cleaning and preparing the data analysis step will start by choosing the data analysis techniques needed to answer the defined questions and to achieve the objectives. This will then help the decision makers to make measured actions based on numbers, not on their gut feelings. The objectives for data analysis may be different from context to another, based on the decision makers' questions that they want to answer for them and that they want to measure, let's say. So let's say for exploring and describing data, maybe the decision makers are interested to find what is the most frequent store that the customers visit. Let's say what is the trend line of our sales. Maybe the decision maker want to measure a KPI, like the number of customer satisfaction, the cost or the budget variance in dollars. Maybe they want to research a topic. Is there any effect of transformational leadership in employee engagement? Is there any effect of internet advertisement on consumer behavior? Or maybe they are interested to predict some future outcomes. What will be our sales for the upcoming year? What is the credit scoring system to approve or deny loans for people? So, in this second topic, we will talk about the relevant data analysis techniques. Descriptive statistic quantitatively describes and summarizes features of data in a meaningful way and helps in finding patterns and relationships between variables. Also, it helps to know how often observations happens, when does it happen, and what is the chance of happening again. Descriptive statistics falls into two main subcategories: univariate statistics, which deals with one variable, and bivariate statistics, which deals with two variables. Let's start with the univariate statistics. In this case of univariate statistics, we can work either with numerical variables, let's say like age, number of employees, sales in dollars, or with categorical variables, let's say the income category, the gender, the educational level, and so on. If we are using numerical variables, we can find the followings, like central tendency measures. It includes mood, median, and mean. The measures of spread, like range, quartiles, percentiles, and standard deviation, or finding the form of the distribution. Is it normal, symmetric, asymmetric, or tailed distribution? In case of the categorical variables, we can only find the frequency of the data. Out of the central tendency measures, only the mode can be interpreted and found. For the bivariate analysis, it is defined as dealing with two variables, as we mentioned previously. Let's say to find hidden patterns or relationships between the variables. In case of two numerical variables, we can mainly use two types of analysis. One is using the scatter plots graphs, which uses graphical presentation to describe the relationship between the two numerical variables, the shape of this relationship, and it may help me to find the trend of the two variables. The second type is second type is correlation and covariance, which they are measures of strength between the two variables. In case of numerical and categorical variables, we use box plots and whisker to describe one categorical variable that includes multiple groups. Like, let's say, educational level categorical variable. It may include, let's say, bachelor degree, master's degree, or PhD and PhD, with a numerical variable that may include the count of each degree level. When we are dealing with two categorical variables, we can use contingency tables, as they are used to transform the qualitative variables into numbers and display the data in a form that makes it easier to count. Let's say we convert the two categorical variables into numbers to count them, or let's say to find the mean, the average, or the standard deviation. Moving to our third topic, that is the importance of sampling and sampling techniques. In the beginning, I want to differentiate between population and sample, as population includes all members of a defined group, like, let's say, total number of customers, total number of employees in the organization, total number of citizens in the country, and so on. Sample is a proportion of the population with selected characteristics that describes the defined group of the population, like, let's say, choosing customers to measure customer satisfaction. So we have some characteristics for this sample. We draw and collect the sample, let's say, measure customer satisfaction from this sample. Let's say random group of the employees to measure employee engagement in the organization, or a random sample from the country, let's say to measure the citizen satisfaction about a new governmental service. So why to sample? There are different causes why to draw a sample instead of collecting the data from the whole population. One of the reasons as we cannot sometimes we cannot gather data from the entire population. So we choose a sample and draw conclusions about the population from the sample using inferential statistics. Another situation, data may be needed urgently, and collecting everyone's response will take a huge amount of time. Another reason, maybe some groups of population are difficult to get access to, or maybe budget constraints prevent from collection information from the whole population. So we use sample instead. We should mention that getting conclusion from a carefully obtained sample is much more better from the results we get from a carelessly conducted census, as it can provide less reliable information. To ensure collecting statistically valid data that represent the whole population, there are different sampling methods that we can choose from. Simple random, systematic random, stratified random, or cluster random, or a multi-stage. As a multi-stage, maybe we will start with a simple random, and then we will draw another sample from this simple random using stratified random. Simple random sampling identify the population that we will draw the sample from, and we choose randomly from the population. We should take into account that each observation does not affect choosing the next one. For a stratified random, we identify the population, then divide the population into different strata, let's say small subgroups, based on similarity, let's say based on educational level, age group. Then we select observations randomly from each subgroup. In systematic random sampling, we identify the population, then we choose the first element randomly. Let's say we choose the third person. After this, we follow a systematic approach by choosing the next element based on regular interval. So let's say we start randomly the first person, then each 4 times we choose person. In the fourth type, a cluster random sampling, we identify the population, then we define the population into different clusters randomly. Then we randomly choose some clusters as samples, and all the elements within each cluster will be chosen. When choosing a sample from the whole population, there are some determinations of confidence level desired and margin of error. Those determinations should be taken into account to ensure the sample size represents the population. So let's say for a sample size of 30 or greater will provide good results in most cases if the population size is small. So as a rule of thumb, the larger the sample size, the lower the likely error in generalization to the target population will happen. So as an example, for a target population of 100,000, taking margin of error, let's say a 5%, and a confidence level of 95%, a randomly selected sample of 383 observations will be enough to draw conclusions about the whole population. So now we are moving to the most important topic when we are dealing with data analysis using statistical tools, the hypothesis testing. Hypothesis testing is used to determine whether a statement about the value of a population parameter should or should not be rejected. Before starting the testing, we should identify null hypothesis and alternative hypothesis. As null hypothesis is the status quo, is the hypothesis assumed true in the hypothesis testing procedure. Let's say there is no observed effect in the experiment. For alternative hypothesis, it concluded to be true if the null hypothesis is rejected. There will be an observed effect for our experiment, and we will have some Excel exercises to identify or to find or to use the hypothesis testing. The hypothesis testing procedure starts by developing the null and alternative hypotheses. We specify the level of significance. We collect the sample data and compute the test statistic, moving to compute the probability value, the p-value, using the test statistics and compare it to alpha. And after this, we interpret the results of the hypothesis test. either by rejecting the null or accepting the null hypothesis. Different hypothesis tests use different test statistics based on the probability model assumed in the null hypothesis. So as you can see, as an example, for a hypothesis test ANOVA, we use the test statistic F test. Let's say for T test, we use T statistic. So we will start with the Z test. Z test is used to determine whether two population means are different when the standard deviations are known, and the sample size is large to test the hypothesis in which the t-test will follow a normal distribution. And this is the shape of the normal distribution. So some examples are, is there any significant difference between the sales in two different locations? Let's say we have some historical data, so this will help us to use the test. So let's say if I want to test if employees' engagement level this year will be equal or above 90% or not, with knowing the previous or the historical engagement variance for previous years. So maybe we want to test if the sales of one company's branch will be above 2 million next month or not. So we will take this exercise to solve Z test using Excel. So let's assume that a higher education want to evaluate the differences in education equality between two universities. An examination is given to individuals who studied at the universities. The differences between the examination scores is used to assess the quality differences between the universities. The population mean for the two universities are mu1 is the mean examination score from University A, and mu2 is the mean examination score for University B. The examination results given previously in different settings always resulted in an examination score standard deviation around 10 points. Thus, this information will be used as will help us that the population standard deviation for both universities are 10. So, an independent random sample of size 30 observations from University A has been collected, and a sample size of 40 from University B were taken. So the task is, do these data suggest a significant difference between the population means at the two universities? As we want to let's say to test the hypothesis if there is a quality differences between educational equality differences between the two universities. So let's move to this exercise. So we got information from the exercise that the standard deviation is 10 for University A and 10 for University B. The variance is always the square of standard deviation. So we have variance for University A is 100 and for University B is 100. So the null hypothesis is there is no significant difference between the universities when it comes to educational equality. And the alternative hypothesis is there is a significant difference between the universities. So to solve this using Z-test, we go to data analysis tool, and we choose two samples means Z-test. So we choose the range for University A, then we choose the second range for University B. As long as we choose in the header and include the header in the range, we should tick the labels. So the hypothesized mean difference is the difference between, as we assuming in the null hypothesis that there is no difference, we put it 0. Variance of A is 100 and variance of B is 100. Alpha is the significance level. Let's say we want a confidence level of 90% when we get to the results. So alpha is 1 minus 95%. We choose the output range and we click enter. From this table, the most important information for us is the p-value. So to compare the p-value, to find, or let's say to reject or accept the null hypothesis, we should compare the p-value with alpha. And we agree that alpha is 5%. So we will compare those two values. As long as the p-values, let's say the p-value is below or equal to alpha, we reject the null hypothesis. So in this equation, the p-value, this is greater than alpha. So in this example, we do not reject the null hypothesis. That means that there is a significant difference between the two universities when it comes to quality in education. So moving forward, we are going to discuss the t-test. So in the z-test, we agreed that we have some historical data that will help us to predict or to test the hypothesis of future outcomes. So in t-test, it is used to determine if there is a significant difference between the means of two groups when their standard deviations are unknown. So let's say we don't have any historical data that will help us to test the hypothesis. To test the hypothesis in which the t-test, it will follow the t-distribution. The examples of t-test, let's say if I want to test if project A return on investment and project B return on investment will be equal after implementation or not, knowing that the company implemented such projects for the first time. So we have no historical data that will support our decision. So let's say if I want to test if the new production line will produce more than 500 items per hour, and there is no information about the production line from historical data. So we will take this scenario. So let's say, assume that a manufacturing company implemented a new production line in its operation to reduce the time required to produce the products. The management selected a random sample of 24 operators to evaluate the new production line. Then, 12 of the operators are instructed to produce the products using the current production line, while the other 12 are trained on the new production and instructed to produce the products. The population mean for the two production lines, let's say mu1, is the mean output completion time using current production line. In mu2, the mean output completion time using a new production line. So the management want to evaluate if the new production line will provide a shorter time of completion. So from this, the task is, do these data suggest any evidence that mu2 is less than mu1? So going back to our Excel. So the null hypothesis that there is no significant difference between mu1 and mu2. That means that the production line, the new production line, will not provide a completion time less than or greater than the old production line. The alternative hypothesis, there is a significant difference between mu1 and mu2. As long as we don't have any previous or historical information, the standard deviation is not known, and the standard deviation of 2 is not known. So how do we find this? We use t-test. We go from data analysis. We choose t-test assuming unequal variances. So we choose the current production line and we choose the new production line. As long as we choose in the header, we take the label. Hypothesized mean difference, as long as we identify the null hypothesis as there is no difference between mu1 and mu2, it will be 0. And let's say we want a confidence level of 99%, we will have 1% value of alpha. We choose the output range and OK. So we will be interested in p-value and we will compare it with alpha again. And we choose an alpha to be 1%. So as long as the p-value is greater than alpha, we do not reject the null. That means that there is a significant difference between production line, the new production line and the old production line. So this information, after we tested the t-test, it will help us, let's say, to make decision to implement a new production line, a second new production line or not, or let's say to dismantle the old production line or not. So moving forward, we will discuss the ANOVA test. So in the previous two examples, we tested, let's say, between two groups. So let's say if I have more than two groups, we will use ANOVA. And ANOVA is used to determine if there is a significant difference between variances of 3 or more groups, and it is the extension of T and Z tests. The ANOVA test will follow the F distribution, and this is the shape of F distribution. For Z test and T test, the test can only be, those two tests can only be used between two groups each time, and it's impossible to compare between more than two groups. So ANOVA is designed to enable the quality testing between two or more independent groups to test whether there is a difference between them or not. So let's say, as an example, the management team or the top management want to measure if the quality level of products using production line A equals the quality level of products using production line B and production line C. So it will be impossible to compare A with B and C using Z test or F test. So we will use ANOVA. Now we will have another scenario to test ANOVA. Let's say that a call center manager is trying to find the best way to staff the agents. The manager is struggling to discover if the need for extra agents is constant across the week or not. So the manager collected data for the number of calls per day for the last month. Considering the center is working 24/7, the population mean for the weekdays are, and those are, you can see that, let's say, mu Sunday, the mean number of calls on Sunday, mu Monday, the mean number of calls on Monday, and so on. So the manager want to test if there is a need to hire extra agents for all weekdays or not. So going back to our Excel. So this is the data. As you can see, he collected the data for 4 weeks during each week. So the null hypothesis will be no need to hire extra agents for all weekdays. The alternative hypothesis, there is a need to hire extra agents. So to solve this exercise, again, we will use the data analysis tool that Excel provides. From data analysis, we use ANOVA single factors. We choose the input range, and we choose only those numbers as it is from B3 till H6. And we choose, let's say we want the significant level to, the alpha level to be 5%. We choose the output range. From those two tables, the most important thing for us, again, is the p-value. We compare the p-value with alpha. And we choose an alpha to be 5%. And we agreed that if the p-value is less or equal than alpha, we will reject the null hypothesis. So in this example, we have the p-value is less than 5% with a confidence level of 95%. That means there is a need to hire extra agents in all weekdays with a confidence level of 95%. So moving forward to the fourth type of hypothesis testing is the chi-square. So in the chi-square is used to test the expected frequencies for categorical data and to test hypotheses in which the chi-square following the chi-square distribution. As you can see, the chi-square distribution is to some extent looks like the F distribution. For simplicity, we are going to discuss the first type of chi-square tests, the goodness of fit, and it focuses on the differences between the observed frequency and the expected frequency, and it is used to determine whether a sample data are consistent or not. and we will take an exercise to show you how to use the chi-square test. Chi-square test is applied when there is one categorical variable from a single population. Okay, so in this scenario, let's say that the employers want to know which days of the week employees are absent in a 5-day work week. Most employers would like to believe that employees are absent equally during the week. So suppose a manager drew and collected a random sample of 60 managers. So let's say a company collected a random sample of 60 managers as they were asked on which day of the week they had the highest number of employee absence. The results were distributed as the below table. So the task, do the days for the highest number of absence occur with equal frequencies during a 5-day week or not? So going back to our Excel file, for chi-square, the null hypothesis, the absent days occur with equal frequencies. The alternative hypothesis is the absent days do not occur with equal frequencies. We will use this equation to help us to calculate the chi-square and to find the p-value. So the degree of freedom, we find it is always the size of the sample minus 1, or let's say the groups. So we have 5 groups and it's 5 minus 1. So to find the expected frequency is always the sum of those values divided by the count of them, as long they are 5. So it's count, and we press enter. We move the whole weeks, so the expected frequency is 12 for each weekday. So using the following equation, we will find the observed minus expected. It is the observed minus expected. And for simplicity, we just drag and drop the other values. After this, we will find the square of the differences is the numerator, and it equals to this value square. And for simplicity, we just drag and drop. Okay, so now we want to find the chi-square. So it will be the numerator divided by the expected frequency. And again, we drag and drop, and we find the summation of those values. And it equals to 3. So to find the chi-square and the p-value of chi-square, we use the equation chi-square test. We have two options, either by using chi-square test, or I prefer to use chi-distribution right. So it will be 3 and the degree of freedom, and we press enter. So we have this value. We compare this value with alpha. Let's say alpha is 5%, and as long as the chi-square value, the p-value of the chi-square test is greater than 5%, we do not reject the null hypothesis. And that means the absent days do not occur with equal frequencies. So now we find the hypothesis testing using 4 different techniques. We use simple examples just for simplicity, as you can apply them in any different situations. So now we will talk about our first topic for this webinar, and it is the impact of data analysis on the decision-making process. So in today's world, as we discussed previously, technology has made collecting a huge amount of data possible, and that leads to having a massive amount of data. So machines, in reality, they do not analyze the data by themselves. People do analyze data people interpret the results, and people make decisions. So let's say analyzing data effectively will give the organization valuable information to help in taking actions. As many companies nowadays, and from a consulting experience, I can see they only focuses on reporting. As reporting itself, it gives us information about what happened in the past. And unfortunately, they are not using data analysis to find, let's say, hidden pattern or hidden information or to test some future outcomes. As analyzing data will help us to uncover the hidden information in data and help decision makers to make more precise decisions about the future outcomes or future direction. So to review, just let's say some notes to keep in your minds. Descriptive statistics quantitatively describes and summarizes features of data in a meaningful way. And population, it includes the numbers or the people, the whole people, let's say in a defined group, the number of our customers, total number of employees. And sample includes a proportion of the population with some selected characteristics. And there are four main types: the simple random, stratified random, cluster random, and systematic random. Let's say when choosing a sample from the whole population, there are some determination, the confidence level, and the margin of error. And the hypothesis testing is used to determine whether a statement about the value of population parameter should or should not be rejected to help us to make future decisions. So now we will go for our questions and our Q&As sessions.
All right. Thank you very much for the presentation. We've got so far 2 questions. So the first one, concerning data analysis and measurement, what does the concept of degree of freedom mean?
So we have a question of how we can choose the value of alpha. The value of alpha depends on the confidence level that you want to choose. So as I show you in the Excel exercise, that let's say that you want a confidence level of 95%. So 95% confidence level, we just subtract 100% from 95% and it will be 5%. And this is the value of alpha with a confidence level of 95.
All right, thank you very much for your answer. And now the second question we have is, why is hypothesis testing?
Another question.
Why is hypothesis testing important in business?
What is the degree of freedom? Degree of freedom refers to the number of values, let's say, involved in the calculation. So we have, let's say, 5 groups. So it's 5 minus 1. So it means that those values are the critical value which you accept or reject a hypothesis and help us to achieve desired confidence level. And those values or those numbers are, let's say, considered that are free to vary. That's why they are called degree of freedom.
All right. So the second question, Fadi, was, why is hypothesis testing important in business?
Okay, when to choose Z-test and T-test. So let's say if you have some historical data that will help you to find, let's say, the standard deviation and the variance of a previously identified data, you will use the T-test, the Z-test. As the Z-test, it depends on the standard deviation of the population, and you can find this from the historical data. While for T-test, you don't have any information from historical data, and we will choose the T-test as it will not depend on the previous or historical data.
All right, thank you very much for your presentation, Fadi. And this also concludes the Q&A session as we have reached our time limit, and it brings us to the end of today's webinar. The KPI Institute appreciates your interest in the webinar data analysis, sampling, and hypothesis testing. Follow our websites and our social media channels to find out more details about our next webinars when they get posted. Also, if you're interested in getting a certification granted by the KPI Institute on vital areas within the performance management discipline, you can explore our scheduled courses on marketplace.kpiinstitute.org. Thank you once again for your participation. We wish you the best of performance and have a nice day.